Welcome to solverfy.
In this problem, we have a double slit experiment. So we have two slits separated by a distance d, which is this space right here between the two black lines, and some distance L away is a screen. And on this screen, we're going to see a fringe pattern with bright spots and dark spots. All right, so the bright spots are these circles and the dark spots are the spaces between them. And the relationship for the double slit pattern for the bright spots is that if this is the angle theta to some bright spot, here it's to the second one, but it could be to any of them, is given that by d sine theta sub n, where sub n means the nth bright spot, equals n times lambda. So n is an integer here. And lambda is the wavelength of the light shining through here. Now in this problem, they're giving us two different lights being shined through the same setup. And they want to know what is the distance between the two third bright fringes. All right, so this would be the third bright fringe over here. I'll do it on the bottom so that we don't have the drawings right on top of each other. So here's a third bright fringe. So this would be theta 3, right? And the distance to theta 3 I'm going to call x. Okay, and if we look at this triangle here, we have that L over x, or sorry, x over L is tan of theta 3. So tan theta, I'm just going to call it theta. We're only dealing with theta 3 anyways. Just remember that n equals 3. So tan theta equals x over L. But if theta is small, then tan theta is approximately sine theta. So this is approximately sine theta. So now we can say that d, and if I just substitute x over L into sine theta, so dx over L is approximately, and then n is 3 we said, so 3 times the wavelength, which gives us that x is approximately 3 lambda L over d. And now we just have to plug in the numbers. So they tell us that d is equal to 5 millimeters, L is 1 meter, and now we have two different lambdas because there's two different lights here. So we'll say the first lambda, the first wavelength, is 480 meters. 480 nanometers. And the other one, which I'll call lambda prime, is 600 nanometers. All right, so now we have to do the x for the 600 nanometers minus x for the 480 nanometers. So I'll call this delta x, which is equal to x prime minus x. And this is going to equal to 3 lambda prime L over d minus 3 lambda L over d. And then we have a 3 L over d common factor, so this is just 3 L over d times lambda prime minus lambda. And I plug all these numbers in, and I get that delta x equals 7.2 times 10 to the minus 5 meters, which is the same thing as 72 micrometers, where micrometer is 10 to the minus 6 meters. And that's the distance between the third bright fringe for one light and the third bright fringe for the other light.